All right, Brayden, so what do we have here? Yeah, tell me about it.
Yeah, so this is the NOVA ESS. It is a 16 kilowatt continuous output inverter with a 16 kilowatt hour battery that we are creating to kind of help with the domestic content market. There's a lot of incentives around that a lot of TPOs and VPPs, and there's organizations that need domestic content and those incentives to be successful. So that is what this series is going to be focusing on. Now, we're trying to, with the NOVA, make it more of the sleek all-in-one style design. And there's a, excuse me, there's a couple of additional things to take into consideration with the NOVA ESS. Now, with a 16 kilowatt hour battery, there is still the ability to expand with DC batteries only, even though it still has this kind of sleek look. We built the conduit box into the battery this time, as opposed to having it as a separate system. So it makes the battery look a little bigger on first glance, but when you put the two together, it kind of ends up being around the same size, maybe a little wider, but height-wise. Still has your inverter at eye level. And now, one of the things with the battery itself, we have a third generation BMS built into it, and that's going to have capabilities with Wi-Fi and Bluetooth if need be. But there's also some stuff with auto addressing the inverter. You don't have to go through, commissioning process. You don't have to go through with setting everything up as EG4. It'll just auto communicate as long as you have your cabling set up properly. And there's a couple of additional cool benefits with the third gen BMS that we're working on, and we'd love to talk about in the future. But do you have any questions about the?
Yeah, I'm curious. So, is it a literal plug and play? Do you have clips that literally just connect it together, or do you still having to supply your own wires and wire it together?
Within the architecture of the wiring box, we still have the quick connect style that our other batteries do, but all of the stuff that's going to be come with the NOVA system will be pre-tailored to this form factor. So you won't have to go and make your own cables unless you were doing something funky with the placement on the system. Trying to make that all-in-one as much as a quick commission and installation time for our installers as possible, because that's one of the big things with an all-in-one system is that it's quick and easy.
Okay, so the main benefit is that it's made in America, right? And so because of that, for installers, it can qualify for the tax credit next year. Unlike the individuals, the DIY guys, my main channel, our audience, we can't necessarily take advantage of the benefits of this being of it being made in America, other than the fact that it just makes us feel better that it's made in America. Right?
Yeah, so as far as made in America content goes, you're going to see that a lot of the stuff that qualifies for domestic content, if you're not making use of those incentives, it doesn't make sense price-wise. You're still going to be looking at, Asian imported content having a lot lower cost, even with the tariffs and stuff that have been, kind of threatened or announced at this point. So we're still going to have two options on that stuff. We're going to have things that will be as cost effective as possible to help satisfy what we kind of refer to as our DIY cash market. Those folks who aren't going to go through all the troubles of trying to even figure out the incentive landscape, they just want to see, how much money they can save at the cost of installation. They don't want to have to deal with everyone knowing all their business. This one is going to be a little bit different of a market, right? There's this one, I would say, is going to be tailored to a lot more of the utility AHJ installers that are going to have a lot more restrictions around their stuff in general.
Right.
Now, we will have our current plans are at least to have 100 volt systems for the DIY / cash market as well.
Right.
Because there are a lot of installers that would like to make use of those high efficiency systems. But we will also carry, our 48 volt stuff and continue to expand upon that, improve it as much as possible too. So
and
there'll
James,
be some options.
I was talking to James earlier, and he hinted that there's more to come on this, maybe a 20 amp hour or 20 kilowatt hour version such. It's coming. I don't know if you can talk to any of that, or maybe we'll just let him
Yeah, well, so
Drop hits.
there's, I can't remember what exact like ruling it is in like NFPA 855, but there's a lot of talk around. There's like a 3-foot rule, 20 kilowatt hour, of lithium content within 3 foot, up to 80 kilowatt hours of a battery bank. So you'll probably see a lot of batteries top out around that 20 kilowatt hour range just for the maximum spatial efficiency. With the 16 kilowatt hour, you could still get your maximum of 80 with having 5 parallel together. But yeah, we're trying to get this up to 20 kilowatt hours with some.
Is that the reason for this case being larger than most 16s?
That might be. There's some engineering that goes into this that is keeping it larger, but it is, I'm going to say, part of it is the conduit box itself giving it an appearance that makes it seem really big. But yeah, this
So I'm
one,
saying, like, I just installed a couple of the LG 16H primes, and they've got the same capacity, but are a lot smaller. So
no, I think those.
and they're a little thicker.
I'm not sure
a little bit thicker.
what cells they use. Yeah.
Well, they're also NMC. So
Yeah. Oh, okay. Are they?
yeah. Yeah.
I wonder. I don't know what the chemical for NMC. I don't know what the chemical density is.
Yeah.
If it's
Maybe it's a little more dense.
I imagine lithium iron phosphate's probably. I mean, these are lithium iron phosphate, by the way.
Okay.
I imagine that these might be a bit larger. And as far as battery chemistries go, those are kind of still evolving. Obviously, lithium iron phosphate's been around for a long enough time for us to be pretty safe in it. And we have, of course, all of the safety features built in to make sure that this is, safe as a lithium iron phosphate can be. But maybe there's options to expand into other chemistries that could be a little bit more chemically dense or more cost-effective, things like that in the future.
Cool.